Hello friends, welcome to the Basics of Geography series, and I will welcome you in this incubation series for civil services examination. I am Rohit Madan here to mentor you so that you can build your concept on basics of geography. And in this session, in this series, we are going to start weathering. So here, first, when we start weathering, what comes in your mind? Because weathering is mostly very important and very crucial to the our human survival. How it is inevitable for the human survivals, because without weathering we will not be okay. जो हम है ह्यूमन सर्वाइवल्स है, विदाउट वेदरिंग वी कांट एग्जिस्ट. तो ये ऐसा माना जाता है कि वेदरिंग के बिना वी कांट एग्जिस्ट. व्हाई व्हाट इज द इंपॉर्टेंस ऑफ द वेदरिंग? वेदरिंग importance. The first one is the soil formation. Without weathering, there is no soil formation. If there is no soil formation, there is no plant growth. But from where we will eat? Okay, so our food is derived from this plant, animals, all living creatures are depend upon the soil formations. The second one is minerals. What minerals we derive from the rocks? It is through our soil formations or through the food and the plants, and that's how we enter into our food web cycle. Okay, so other types of the, because rocks, if you look at the rocks and the minerals, they are not so important to us, but when these rocks weathers, they into converted into a useful minerals. So if you look at the weathering, weathering is very important to us. Okay, it is not important to us, it is important to the human survival. Okay, without weathering we can't exist. So this is how we have to understand the importance of the weathering. So this is the importance of the weathering. Okay, this is our questions. Define weathering and distinguish between the two main categories of the weathering. What are the two main categories of the weathering? The physical weathering and the mechanical weathering. So before we start and to classify the weathering, first we have to understand the what is actually weathering. Weathering is a process. Okay, it is in a physical disintegration as well as chemical alterations. Physical disintegration, one point, and the second point is chemical alteration. So weathering involve the physical weathering, also mechanical, that is mechanical weathering, and as well as chemical weathering. Okay, now look at what are the two basic categories of the weathering. The two basic categories of the weatherings are mechanical weathering and chemical weathering. So what is mechanical weathering and what is chemical weathering? Now look at, first we have to understand why does rock weather. Weathering is a manifestation. Weathering is a manifestation of the changing response of the earth material to a changing environment. Weathering is a response or a manifestations of the earth material to a changing environment. Okay, so this is how we have to understand why rock weather. Now look at the mechanical weathering. What is mechanical weathering? What is mechanical weathering? Broken into smaller and smaller pieces. Broken into smaller and smaller pieces, and each smaller pieces retain the characteristic of the original materials. If any rock broken into smaller and smaller pieces, and each smaller pieces retaining the characteristics of the original material, so this type of the disintegrations, this type of physical disintegration, we call them mechanical weathering. Because breaking of a rock into smaller pieces increase the surface area available for the chemical attack, and this is how physical weathering, that means mechanical weathering, is effective to the chemical weathering, and how mechanical weathering increase the effectiveness of the chemical weathering. So this is how mechanical weathering add to the effectiveness of the chemical weathering. Because if you look at this block, this has a surface area. Okay, this has some x. Let's assume this has an x as a surface area, but when this goes under a physical disintegration, it has an upper types of the 4 blocks, and these are the 4 blocks. This has an 8 blocks. So this surface area will be increased by 8 times. and this will be increased by 32 times if these are the all blocks. If we count, if these are 32 blocks. So this is how if any rock undergoes a physical disintegrations, it's led to the effectiveness of the chemical weathering. How? Because of the increased surface area. So because of the increased surface area, it adds to the effectiveness of chemical weathering. So four important physical process leads to the fragmentation of the rock. What are these four processes? The first is frost wedging, the second one is salt crystal growth, third one is seating, and the fourth one is biological activity. Let's one by one. What is frost wedging? So when in any joints or any fractures, water enter and it's freeze. So when water freezes, it increases its volume. Okay, so when volume increase means because if this ice, if this water enter into these fractures and it freeze, it becomes an ice wedge, and this is how it increase the area of the joint of the fractures because of the fractures due to its ice expansion. So when ice expand, the जो area होगा that it is joint है, वो क्या होगा, वो expand कर जाएगा, so it will goes to expand. So why frozen water expand? Because of the crystallizations of the liquid water into the ice. So when liquid water undergoes the crystalline structures, when it becomes an ice, so this area increases because of the crystalline structures. So because of the intermolecular space. So when water freezes, because of the intermolecular space, frozen water expand. Okay, and if frozen water expand, it creates a frost wedging. Frost wedging can also occur in different ways, like when moist soil freezes, so it creates a frost heave. It creates a frost heave. So due to the growth of the ice lances. So when ice lances grow, it creates a frost heave. These masses of the ice grow larger because they are supplied with the water migrating from the unfrozen areas to the thin liquid films. So a similar process occurs within the cracks and porous space of the rocks. So this is how frost wedging took place, and frost wedging creates a mechanical weathering. So this is an example of the frost wedging. And in changing climate situations, in climate scenario, if our glaciers are retreating, and glaciers phenomena has become very seasonal in some mountains area because of the when snow comes and it creates a crystalline ice that form a glaciers. But in the upcoming or in the subsequent अगर जो warm seasons आता है, summer seasons आता है, तो this ice melt, and because of that a frost wedging become a very dominant and predominant features of the mountainous areas. What is salt crystal growth? What is salt crystal growth? So where it occurs? It occurs in the rocky shorelines and arid regions are the common setting for this process. Why? Because it needs a salty water and high temperature. So how it occurs? It begins when sea spray from breaking waves or salty groundwaters penetrate the crevices or the pore space in the rock, and this water enter into the crevices or the pore space in the rock, when it evaporates, salt crystal forms. So because of the growth of the salt crystals, so a rock expand, and because of the expanding of the rocks, mechanical weathering took place. So mechanical weathering is simple. It is in a physical disintegration, and how this is salt crystal growth creating a ground for the mechanical weathering. What is seating? What is seating and where it happens? So first look at the where seating happens. So when large masses of the igneous rocks, particularly granite, are exposed to the earth's surface by erosion, concentric slabs begin to break loose. Why? Why this happens? The why seating happens? Because this granitic mass hai, this granitic mass is in plutonic. Plutonic means this is igneous body. So when erosion took place, so because of the erosions, upper mass will be washed away. If upper mass will be washed away, there is a significant pressure release. There is significant pressure release. And because of the release of the pressure, some parallel joints develop. And because of the parallel joints, seating took place. And every season there is a seating took place. So this is how seating happens. What is seating? The process that generates these onion-like layers we call seating. So onions-like layers जो होती है, we call them seating. Why it happens? Because of the unloading and exfoliations dome. Because of the exfoliation dams and the unloading, it causes seating. So this is an example of the seating. If this is in a deep plutons and this deep pluton has a confining pressure because of the upper mass, but when this upper mass was away by the erosion, and this led to the expansions and seating because of the parallel joint developed in this dome structure. Now look at the example like the stone mountain of Georgia and the half domes. These are the example of the seating. What are joints and how do they promote weathering? Joints क्या होते हैं and how do they promote weathering? Because we know that although many fractures are created by the expansion and the contractions of the molten rocks, and also from the tectonic forces during the mountain building. But when these fractures have some patterns of growth, we call them joints. So joints are the important rock structure that allow water to penetrate, to depth, and start the process of weathering long before the rock is exposed. So water play a significant role in mechanical as well as chemical weathering. Like in chemical weathering, in dissolution, oxidation, on mechanical weathering, in the frost weathering, salt crystal growth, water has played a very significant role. These are the joints, and in joints when water enter because of the frost weathering, dissolution, oxidation, and hydrolysis, so water plays significant role in the weathering. Now look at the biological activity. How biological activity promote weathering? So biological activity, weathering can be accomplished by the activities of the organism, including plants, burrowing animals, and the humans. How? Like this is in a plant. The plant root, when plant root extend into the joints and grow in diameter and length, this process enlarge the fractures and the break rocks. तो plant root very अगर आप देखोगे plant roots क्या करते हैं, when they extend, the जो fractures होते हैं, they expand and the rock breakouts, and this is how it increase the surface area, which where chemical weathering will accelerate. Animals, how animals, burrowing animals further break down the rock by moving fresh materials to the surface where physical and chemical process can more effectively attack it. Okay, decaying organism also produce acids that contribute to the chemical weathering. What is chemical weathering? So chemical weathering, as we have understand, chemical weathering is a chemical alteration. Okay, so chemical weathering involve the complex process that break down the rock components and the internal structure of the minerals. So if any rock undergoes chemical weathering, can it be reversible or irreversible? So chemical weathering will be irreversible. Okay. If wooden block is burned out, so this is an example of the chemical weathering. Rusting is an example of the chemical weathering. So chemical weathering involves the complex process that break down rock components and internal structure of the minerals. Such process convert the constituent to new minerals. Either it forms new minerals or release them to the surrounding environment. If these are released to the surrounding environment, they become part of the rock cycle, either of the rock cycle, and through rock cycle they enter into our food cycle. They enter into our food cycle, from where we draw minerals. Okay, so this is the how chemical weathering took place and how it is important to human. Water, agent of the chemical weathering. Why water is known as the agent of the chemical weathering? It is because of this bipolar nature of the water. Because water is bipolar and it has a universal solvent. So because of the universal solvent natures, it played a significant role in the three types of the chemical weathering, like dissolution, oxidation, oxidations, and the hydrolysis. And water play a leading role in each of these. What is dissolution? So how dissolution promote chemical weathering? So how dissolution promote the chemical weathering? Just as the sugar dissolve in the water, as so to do certain minerals also. So in the same way as sugar dissolve in the water, so certain minerals like the halide and the calcite, they also dissolve in the water, and this is how they promote the chemical weathering. This is the nature of the water, because water has a bipolar nature, because two hydrogen atoms are on the same side and oxygen on the same side. So this is as a bipolar nature, and this is how this attacking power of the hydrogen ion and oxygen ion increase, and this is how oxygen react to the sodium and create a ground. That is how dissolution took place, because of the bipolar nature of the water. Now, most minerals are insoluble in pure water, but then how dissolution took place? If most minerals are insoluble, it is because of the certain chemicals, okay, certain like they say carbon dioxide, sulfur dioxide, they form weak acids, and this is how they enter into the pure water. Because of the acidic nature of the water, this create this increase the power of the water to soluble, and that's why minerals are become soluble in the acidic water. So the presence of the even a small amount of the acid dramatically increase the corrosive force of the water. So what acid do? Acid increase the corrosive force of the waters dramatically, and thus causing dissolution. Okay, so an acidic solutions contain the reactive hydrogen ion. So it जो corrosive forces होती है water की, how it increase? Because of the presence of the hydrogen ions, and hydrogen ion के चलते corrosive force of the water increase dramatically, and this is how dissolution took place in the acidic water rather than in the pure water, because most minerals are insoluble in pure water, but most minerals are soluble in the acidic water. How acidic water produced in nature? In nature, acid are produced by number of process like acid rains. Okay, we release the carbon dioxide. So carbon dioxide also created when carbon dioxide in the atmosphere dissolve in the raindrops. So carbonic acid produced. So various organic organism जो होते हैं, organic acids are also released into the soils as the organism decay. So sulfuric acid is also produced by the weathering of the pyrites and the other sulfide minerals. Okay, so this is how in nature certain acids are produced, and this is they made in a water as acidic natures, and this is how they increase the corrosive power of the water, and this is how dissolution took place. Now look at the how acid help in the chemical weathering. How acid help in the chemical weathering? Because of the acidic nature of the water, like this carbonic acid and hydrogen ion dissociate from the bicarbonate ion, and this hydrogen ion attack on this calcium ion, and this is how calcium ion separate from this bicarbonate ion, and this bicarbonate ion is soluble. This is soluble in water, and now this calcium ion is readily available as in minerals which enter into the rock sites or in the sea later. Okay, so during this process, the insoluble calcium carbonate is transformed into the soluble product. So this is how acid help in the chemical weathering. Now look at the karst landforms. So karst landform is a result of the dissolution. Dissolution is a chemical weathering. Okay. So in nature, over a periods of the thousands of the year, large quantities of the limestone. Limestone means calcium carbonate. So this calcium carbonate, as we saw this example, when HCO3 attack, H2CO3 attack. So in nature, over the periods of the thousands of the years, large quantities of the limestones are dissolved and carried away by the underground water. Because of the underground, so karst landform is a result of the underground water. Okay, so this activity is largely responsible for the formation of the limestone cavern. So this is an example of the karst landforms. Okay, how dissolution produce hard water? So the soluble जो ions होते हैं, the soluble ions from the reactions of this types are retained in our underground water supply, and these dissolves and are responsible for the so-called hard water found in the many locales. Okay, so this is how hard water produced. So what is oxidation? Oxidation means electron loss of the metals. So this is how this process of rustings. So what is rusting? Rusting is an example of the oxidation. Rusting is an example of oxidation. The process of rusting occurs when oxygen combined with the iron to form a iron oxide. So this is iron. So when this iron loses an electron, when it reacts to the oxygen, it forms a iron oxide. We call them hematite. So these hematite or limonite are also important cementing and coloring agent in many sedimentary rocks. And here we can understand the importance of the rusting. If rusting will not took place, that means chemical weathering is not sedimentary rock is not going to form, because when sediment took place as sedimentation and lithification, so these limonites or hematite work as a cementing agent, and this form in a sedimentary rock. So this is how from sediment to sedimentary rock how rusting took place, how rusting helped. Which minerals more susceptible to the oxidation? As we know that the rusting is more susceptible to the ferromagnesium minerals. So these are the olivine, pyroxene, hornblendes, and biotite. These are the ferromagnesium minerals. So this is an example of the rusting. How these are the some iron ore sites. In iron ore sites, we look at this because of the presence of the water moistures, and this took place. This is reddish colors is an example of the hematite, and this yellowish color is an example of the limonite. This is also example of the rusting. Condition for oxidations. Oxidation can occur only after iron is freed from the silicate structures by another process called hydrolysis. Hydrolysis के बिना oxidations will not occur. Okay. So why this so? Other example of the oxidation, when sulfide minerals such as pyrite decompose. So sulfide minerals pyrite is frequently associated with the coal deposits and of metallic ores. Okay. What environmental hazard it may cause? Means in most environment, chemical weathering of pyrite means iron sulfide yields sulfuric acids, H2SO4 and iron oxides. तो अमाउंट जो abundant rainfall है, abundant rainfall infiltrate the soil banks, waste material left after coal or other minerals are removed from the iron ore sites or other metallic ore sites. This is so called acid mine drainage. Eventually makes its way to streams and killing aquatic organism and degradation of the aquatic habitat. So as we know that weathering is also important to us, but weathering also can create a hazardous to us. But it has a major influence of the human activity, because we know that iron ore sites are created by the human for its useful, to remove, to extract the iron materials or other metallic materials. So when abundant rainfall took place, so it infiltrating into the soil banks, and this is how it created acidic solution like sulfuric acid solutions or other iron oxide solutions. So this is example of the acid mine drainage. Now, what is hydrolysis? What is hydrolysis? The most common minerals group, the silicate, is decomposed primarily by the process of hydrolysis. So the hydrogen ion attack and replace the other positive ions found in the crystal lattice. So this phenomena is known as hydrolysis. So when hydrogen ion attacks and replace the positive ions from the silicate minerals in the crystalline lattice. So with the introduction of the hydrogen ions into the crystalline structures, the original orderly arrangement of the atoms is destroyed and the minerals decomposes. So this is how hydrolysis took place. So types of the hydrolysis in the presence of the acid. So hydrolysis in the presence of the acid. In nature's water usually contains other substances The most common mineral group, the silicate, decomposed primarily by the process of the hydrolysis, and hydrolysis in the presence of the acid. In nature, water usually contain other substances that contribute additional hydrogen ions, thereby greatly accelerating the hydrolysis. So hydrolysis will be more effective if it has a more hydrogen ion. Now, how it happens? If water has an acidic nature, so it will accelerate its hydrolysis power. The most common of these substances is carbon dioxide, which dissolve in water to form carbonic acid. And this carbonic acid is very helpful in the hydrolysis. How a rock undergoes hydrolysis in the presence of the carbonic acid. So in water, carbonic acid dissociate to form hydrogen ion, that is hydrogen ion H plus, and bicarbonate ion SCO3 minus 2. So hydrolysis of granite consists mainly of quartz and potassium feldspar. How this happens? Hydrolysis of the continental rock. The weathering of the potassium feldspar components of the granite is as follows. When this is potassium feldspar, potassium aluminum silicates. So when this potassium aluminum silicate is attacked by the carbonic acids, mainly by this hydrogen ion, it replaces the calcium ion. This replaces the calcium ion and form the product kaolinites. This is in a residual clay. So if feldspar took place under the hydrolysis, it produced a residual clay, and this is potassium ion. This potassium ion ultimately enter into the rock cycle. Okay. So what happens in the reactions? In these reactions, hydrogen ions attack and replace the potassium ion. As I told you, potassium ions in the feldspar structures, and thereby disrupting the crystalline networks. Once removed, the potassium is available as a nutrient for the plants or become the soluble salt potassium bicarbonate, okay, KHCO3, which may be incorporated into the other minerals or carried into the ocean. So why weathering is important? Why hydrolysis is important? We can understand from this, like this मीन्स दिस, अगर हम देखें इसको हम पढ़े तो हम समझ सकते हैं कि कैसे हम इसको देख सकते हैं कि वेदरिंग क्यों इंपॉर्टेंट होती है. So product of the silicate minerals weathering. If silicate minerals, particular silicate minerals undergoes weathering, so these are the product list. If quartz undergoes weathering, it will produce quartz grain. Why? Because quartz is highly resistant to the weathering. But if feldspar undergoes weathering, it will produce clay minerals. Okay. If amphibole has an andesitic nature, so it will produce clay minerals, but certain ferromagnesium minerals also present in this. So that's why this also produce limonite or hematite. Olivine is ferromagnesium minerals. That's why it produce limonite and hematite. So this is how product of the silicate minerals weathering. Now we will look at the rate of weathering. What factor determine the rate of weathering? Now summarize the factor that influence the types and the rate of rock weathering. Okay, factor affect the rate of weathering. There are two factors: the rock characteristic and the climate. What include rock characteristic? Rock characteristics include the mineral compositions as well as the solubility, and also the physical features such as joints. They also affect the rate of the weathering. How joints affect the rate of weathering? Because joints produce a open space where it can important, because they influence the ability of the water to penetrate the rock. If some water is penetrate into the rock, this also influence the rate of the weathering. So here we can see the solubility. If certain minerals are soluble in the water, this also increase the power of the water as dissolution, oxidation, as well as into hydrolysis. So this is an example of the two structures. One is made of the granite, okay, and other is made of the marble, a calcite rich metamorphic rock. So this is an example of the calcite rich, okay, and this is an example of the granite. So if you look at the in the same period, okay, this granite headstones was erected in the 1868. So the inscription is still fresh looking, okay, but this monument is composed of the marble, a calcite rich metamorphic rock. The headstone was erected in 1872. Okay, it is erected in 1862, in the 1868, and it was erected in the 1872 in the same period. Okay, but if you look at the today, okay, this is still looking fresh, but this is weathered away. Why? Because of their mineral composition, and mineral composition affect the rate of the weathering. We know that this is made of the granite. Okay, so quartz, it has a quartz. So quartz has a resistance to the weathering, but calcite, because this calcite minerals, we know that these are readily soluble in the water, and that's why it is most weathered. So we can see the example of the different mineral composition and how they affect the rate of the weathering. Now look at the rate of the weathering. The silicate, the most abundant minerals group, chemically weather in the essentially the same order in which they crystallize, as we have understood through the bovine reaction series. Through bovine reaction, in bovine reaction series, we have understand the presence, the sequence of the crystallization of the different minerals. Okay, so if you look at here, olivine crystallize first, because the ferromagnesium minerals crystallize first, like pele ultramafic, then mafic, okay, then andesitic, then felsic. So this is in the same way, olivine crystallize first and is the therefore the least resistant to the chemical weathering. But if you look at the quartz, which crystallize last, is the most resistant to the weathering. So this is how the rate of the crystallization also affect the rate of weathering. Climate, how climate affect the rate of weathering? Climate factors, particularly temperature and precipitate, are crucial to the rate of the rock weathering. For example, the frequency of the freeze and the thaw cycle greatly affect the amount of the frost weathering. Okay, so this is how climate affect. So temperature and rainfall, how temperature and rainfall affect the rate of the weathering? Temperature and moistures also exert a strong influence on the rate of the chemical weathering and determine the kind of amount of the vegetation present. Okay, so regions with less vegetation, a region with less vegetation often have thick mantle of the soil rich in decayed organic matters, and from which chemically active fluids such as carbonic acids and humic acid derive. If such organic matter release this chemically active fluids and it enter into the water, and water become acidic. If water become acidic, it will increase the corrosive power of the water through dissolution power, okay, or oxidation power, and its hydrolysis power, and this is how it promotes the chemical weathering. Okay, why chemical weathering is in polar and arid region is ineffective? If you look at the polar region, in polar region, though water is present, but this water is locked into ice crystal. So that's why chemical weathering is ineffective in polar region. If you look at the arid region, moisture is completely absent. That's why chemical weathering is ineffective. So that's why chemical weathering in polar and arid region is ineffective. Differential weathering. What is differential weathering? Because we know that the minerals in which sequence minerals crystallize, in that sequence they also have a resistance to weathering, and because different minerals have different rate of weathering, that's why they produce a landforms which is very spectacular rock formations and landforms produced by this differential rate of weathering. So look at this example, because of the different mineral composition, because we know that what is rock. If we know that rock is an aggregate of the different minerals, and different minerals have a different rate of weathering because of its chemical composition and solubility. Okay, and that's why these type of structure produce. Okay, so this is how we have seen the weathering. Okay, now in this session we have covered the complete weathering. Okay, if you like our videos, please share and subscribe our YouTube channel IS Conclave. Thank you guys.